Hello, so today we are doing this problem called top k frequent elements, and this problem is a medium problem on Leetcode, and it says we get a non-empty array of integers, and we want to return the k most frequent elements. And so we have this array here, and you can see that the two most frequent elements here are 1 and 2, right? For this one, the first most common element, there is only one, so it's 1. So the constraint are k is always valid, is between 1 and the number of unique elements, and our complexity should be better than O log n or any of the array size. So that's the problem. Now let's try to solve it. So the first way we can use this is kind of leverage a useful Python thing called let me just have this. Okay, so Python has this thing called collections that we can import that allows us to use something called counter that just counts the number of elements. And so if I kind of say collections dot counter for, let's take this array here, can import collections. You can see it gives me each element and the number of its occurrences, right? So with that, it has also an additional method that we can use, which is most common, right? So most common, that gives it gives the k most common elements, and k in our case here, let's give 2. So you can see we get the element, how many times it occurred, and we get the k most common ones. So we could use this one and just take the so the result that we want is the element, and so just take the elements, return the elements, right? So we could definitely use this, which would return a very quick solution. So not quick in terms of time complexity, but like in terms of writing it. So we will take the most k elements, and we'll pass here the number of elements, and we would have, after that we need to return the element value. So that would be, so here it's in the first position, right? So that would be x0 for x in that, right? And that would be pretty much it. Submit. So that solution passes, but this solution is definitely not ideal because we are using a lot of custom, especially in an interview, because we are using a lot of Python custom things, like this collections counter, and the most common that we don't really know the complexity of it. We have to go dig into Python code and see what the time complexity of each. So what are other alternatives? So we can use a heap, right? So we can use a heap as always with these kind of most common things, or the least common, or the most common, or these kind of functions, or the k smallest, or whatever method that has some kind of, or the statistics things, we can use a heap and just handle it that way. So we can use a mean heap, for example, but first we need to determine the frequencies of each element, because we will need this. So we need to calculate frequencies of each element. So we need to do that, and then we can have a min heap that contains, let's say, a pair of frequency and the number, right? And then go through the numbers and add the pair, like the ones we had above, but do an additional step that if whenever the min heap length reaches k, then then pop the smallest element, right? And that would mean just pop in a min heap, right? Popping the smallest element in a min heap is just using pop, because by default that's what pop does, right? And so this way we guarantee that there will always be k element, the k most frequent element. So let's say we have the numbers here. Let's say we traversed a1, a2, a3, ai, and then until an. So at each point here, at each ai position, we know that the min heap contains the k most frequent element from a1 to ai, right? So that at the end, when we reach the end, we have in the min heap the most frequent k elements from a1 to an. So we have the entire array, the k most frequent elements in the entire array, right? And that's what we need to return. So let's do that then. So the first thing we need is the frequencies, to count the frequencies, right? So we'll just use this method called getting the default dict int, which basically just means that the only thing this one does different is that, so it's like this. So if we do frequent of 1, which we haven't added yet to the frequency map, it will still be 0. So by doing that default dict, we make it so that if the element is not present, it has already a default value of 0. So that we can, like, even for one that it doesn't exist, like frequency of 2, we can add 1 and it would be 1 because it was initialized to 0. So that's the first step. After that, we need to go through the array and just say increment the frequency of each number we found. And after that, we need to start our heap. Let's call it that. And we need to go through the numbers in frequency here. And we need to push. So that would be through heap q. So let's import that. So we need to import heap q, and once we do that, we will need to add the element. And now that we pushed for heap q, so actually what we said, we need to push the frequency in the number. So to do that, I'm going to push frequency num and num. And we need to do the check whenever min heap reaches k. So if length of is bigger than k, that means we can pop the smallest element. We want to guarantee that we only have the k most frequent element at the heap every time. And so to do that, we're just going to pop the smallest element by doing heap pop. And then after that, at the end, we know we have only the k elements in the heap, right? And so let's have result. And let's say while there are still some elements in the heap, we can just append them by taking the smallest. So that would be heap q.heap pop, and pop that element and return res, pretty much. Let's see the order. What does the problem ask us? So the problem seems to want them in the most common to the least common. So, but in our problem here, since we are using heap pop that returns the smallest, the one with the smallest frequency, we will have the smallest frequency first and then the largest frequency after that. And so we need to reverse the results so that we can get them in the right order. And the way to reverse in Python is just this way. And that's pretty much it. So let's run this. Okay, so here I need to get it. I'm not interested in the frequency, I'm just interested in the element itself. So we do that with this. And that works, so let's submit. So that passes. So now we did with this heap. There is also a handy method in Python that allow us to skip doing the custom logic, which is using, it's always better to do it without the custom fancy language construct, I think, in an interview. But just to show you how you can do this, it's with, there is this and largest, that gives of k, and so that gives you the largest k elements in an array like this, for example. So if we have nims equal to this here, and we do n largest k, let's say our k is equal to 2, to give us the we need to import heap q, sorry, heap q. And now let's say our nims is this, our k value is this, and now we want the two largest, so we get 6 and 5. So that's what this function does, but it has you can provide it with a key. So let's say I want the n largest squares values, that just something like that. So I would say key, my key that I want the comparison to be done by is whatever value I get, and then I want the square 2. And so yeah, it's the same because that's how it works, but yeah, so you can customize the key. It doesn't have to be just the value. And so that's what we are going to use here. So we have the frequencies already, right? And so what we want to return is just the largest frequency ones, the largest frequency k ones. So the k is this one. The values are in the list that we are concerned with is the keys of the frequency, right? The keys, which are just the numbers, right? So we can use nims as well. But what is the key? The key is the frequency of the element. So it's frequency of, so lambda x, frequency of x, right? So that's pretty much what we want. So that seemed to work. It does work, cool. Now we can adjust this a little bit. So we can say this here, right here, actually, this here, this is just getting the value from the map, right? So we can just say, and remove the lambda x, and you can just say get, right? That's the same thing. Just some useful method in Python. And the other thing is this calculating the frequency here. Python has another method that does this. Again, we should probably not use it in an interview, but it's useful to know about, which is just counter. That just gives us the number of occurrences. The same thing that we did manually. Okay, so that also passes. Now the next thing we can use is actually it's QuickSelect. Sorry. So we can use QuickSelect, which is pretty good at these kind of problems where you want to select the k most things based on some criteria. And so, but with QuickSelect, we still need to count the frequencies like we did here. But we need to do our QuickSelect, of course. So we need QuickSelect and a set of values, left, right, and we need the k that we are looking for. And just to make this easier for myself, I'm going to pass in instead a pair instead of a map. It's easier to work with an array. So I'm going to pass count for these two in the items of frequency, right? And then I'm going to call QuickSelect on the items as the values. I'll just call these values, right? And start from the first element and with the last element, and I want to find the k most frequent ones. But since k here, when it says 2, it wants the 2 first, so the one at 0 index and the one at 1 index. So what I'm going to say is k minus 1, just so that my indices with the array work out because I want in the array I'll start indexing from 0. And then at the end I will get these values handled and parsed correctly. So I would say let's say just values equal to this, right? And so I could just return what do I want? I want then the most frequent k elements. And so to do that, since this QuickSelect will put the most frequent, so my QuickSelect would put the most frequent elements on the left side of the array. So this is how I'm going to do it. But some QuickSelect, when they are looking for the kth smallest, put the smallest ones to the left of the array. And so that's, yeah, depending on the problem, you can put the bigger ones to the left or to the right. Here I'm going to put them to the left. And so I want to return the number itself. And so for and considering my QuickSelect will give me the most frequent elements on the left, that means I can take just the k left element of values, and that's pretty much all I need to do. So now let me write the QuickSelect, which is check first the base case that the left side is equal to the right side. So we have just one element, so we can just return values. We are done basically. Otherwise we need to partition the array, and the partition we need to give it values left and right. And so we need to define here a partition function that partitions the array based on some pivot that we'll write later. Now let's check if k that we are looking for, so we are looking for, let's say if we have an array like this, and let's say I'm looking for the k most element. So I want a way so that all these are smaller than the pivot. So let's say my pivot is here. After the partition, my pivot is here, and here I have all those bigger than p in frequency, of course. So here what we are talking in terms of frequency, not value, and here smaller because I will put them on the left side. Then if k is less than p, which means I want, let's say I want the 4 most frequent elements. And my p is at index, my pivot basically index is at, let's say, for it to be bigger, let's say at 6. And here I have the most frequent ones. So that means I need to look to the left to find the 4 most frequent ones, because if I go here, I will find those that have frequency 7, 8, that have frequency less than those on the left, because those have frequency bigger, right? So I need to go to the left side. And so to do that, I will need to do QuickSelect on values. And since this is left side, this is right side, so I'm going to the left side, so my left side would be still left, but my right side would be the index here -1, because I know p is not part of it, because p has less frequency. And so otherwise, if it's bigger, so k is bigger, so let's say I want the k most frequent ones, and p has rank 6 in terms of frequency. So I know if I want the 8th ones, I need to go here so that I can have them all on the left, so that I can include this portion to get the 8 most frequent elements, right? And so to do that, I'm going to QuickSelect on values left. Actually, my left is going to change because I want to start looking just from p+1, so that I can really reduce the space and get to this base case. And so I'm just going to look at this portion, because this portion I already know it's part of the most frequent. It's the most frequent 5 elements, right? With p, I already know the 6 most frequent elements. I just need to find the other 2 ones. And so my left is going to be p+1, my right is going to be r, and my k is going to be k still, right? And once I do that, that's pretty much it. Now I have my QuickSelect. I need to write my partition function. And so let's just say, so partition, the normal way is just to keep track of. So what I want to do in my partition is, I'm going to take my pivot as the right position, right? So I start out this way. So what I want to do is go through the array one by one and have an index here called store that, let's say my pivot was, let's say the elements have frequency like this. So the first element is the frequency because we did this, and the second element is the number. Let's say I have a number at frequency 4. Let's say that N1, and then I have a number with frequency 2 and 2. So I have another one, frequency 6 and 3, and then I have let's say 4 with N4, or let's give it 3, and then let's say I have an 8 with frequency N5, right? And so, or let's just give them numbers. So 1, 2, 3, 4. So the numbers don't matter, the frequency matters. So my pivot will start out here. So my pivot will start out as here because I'm putting it in the right position. And what I'm going to do is, what I want to end up with is, I want to end up with all those with frequency higher than the pivot to the left, and those with frequency smaller than the pivot to the right? And so actually, to make that work out, let me just put 2 here. And let's say this one has frequency 1. Let's give this one frequency 1. And so first I will start out here, right? So I will start out at this position with my store position, right? And that's, I'm going to do a loop here for range from left to right. So I can go through the entire array except the final element, the pivot. I don't need to do that. So what I will check is, I will check if the frequency value is bigger than that of the pivot. If it is, that means that it should be on the left side. If not, it should be on the right side. And so I would say if values, to get the frequency, I will say values I, and then 0. If that is bigger than the frequency of the pivot, which is at the right position, then I want to swap. But here it happens that it's already at the right position, but if I was, and so I will keep it in there and then advance my store value and then check, advance my I value, right? And also my store value. And then I will find out that 1 is actually smaller than the pivot frequency, right? And so this one needs to move to the right. And so I need to swap this one. To the right. So this one is smaller, so I will keep it actually. But my store value will stay here, so I will not change it, and my store value is here. Because it's smaller, I don't change it, right? Because at the end, I will just keep all of them at the, you will see what I mean. And then I will advance store here. And store, it doesn't advance, store is still at this position, because what I do here is that, so I advances to the next position to compare it. But store, I will advance it only if I find a bigger value, which I did earlier. And so for 6, it's bigger than 2. So now we entered this. So what do we need to do? We need to swap this with whatever store is at, because that's one of the elements that should be on the right. And so I will swap this one with this one. And so to do that, I will say values at store needs to be swapped with the one at I, right? And then I need to advance store so I can handle the other values, right? So I need to advance store to here. And so to do that, I will do store +1. And now this one is smaller than the pivot again. So we skip that one. We don't enter this if check. And we continue. Now 3 is bigger than this one, right? So we don't continue actually. So store stays here. Remember, store does not gets incremented only if we found one that it has frequency bigger than the pivot. But our I increments to the next position using this for loop. And now 3 is bigger than the pivot using this comparison. So we need to enter here and swap this one with the store one. So we swap. And then we increase store, right? So we increase store, so store advances here. And now, since our I reached the right position, we are done. We don't enter because Python range stops at the value just before the whatever is here. And so now that we are done, what do we need to do? We need to put the pivot between the larger frequencies and the smaller frequencies, which are this one. So we need to swap pivot with the store value so that it can be in the middle between both of them. And so that's what we will do here, which is at the end, we will swap nim's store with the pivot, which is at nim's right. And now what is my pivot position? This is my pivot and its position is store, so I need to just return store. And you can see here I have all those with frequency bigger than 2, they are on the left, and all those with frequency less than 2 are on the right. And so all I need to do is return the k elements from these, which I'm doing here at the end, right? And that's pretty much all there is to it. So let's run this. Yeah, so my QuickSelect here didn't return anything, so I should return whatever result I get after the swapping. So item 1 so values has count and number, and I'm returning number. So maybe there is something wrong with values. Let's see. Yep, so one thing I did wrong here is there is no nim, it's values. That's what I get here. And yeah, cool. So I need to see what's in values. So still have a syntax error. Actually, let's just not return it. Let's just make the changes in place, which we are doing with this partition here. That would be simpler. Yeah, for item in values actually. Okay, so that looks good. Okay, so that passes. So you can see QuickSelect here, this check here is really flexible. We can do whatever we want, and it doesn't have to be the array values, it can be anything else. And so to just mention the time complexity for this, so this is QuickSelect. QuickSelect is open in terms of average or best case complexity, and it is open squared in worst case. And in terms of space complexity, the only extra space we are using that is not constant value is the this recursion here, which ends up being open at most. Yeah, so this is pretty much it. I have another video on QuickSelect that explains why the time complexity is this one, So you can take a look at that, and yeah, that's pretty much it for this solution. Thanks for watching, and see you next time. Bye.